Hi students, today we are going to study about memory, that is random access memory. Okay, so this random access memory or RAM is a read or write memory. So dynamically we can read and write. Okay, read and write operation will be performed simultaneously. Okay, so this RAM is the data memory or the working memory of the controller or processor. Okay, so whatever the programs we are executing, all these programs will come to RAM, and from the RAM only it will execute. Okay, so that is a peculiarity of random access memory. So this random access memory is volatile. Okay, so it is an volatile memory. Okay, so if the power is turned off, all the contents are destroyed. Okay, so it is not capable of storing the data permanently. Okay, so RAM is a direct access memory, that is the processor will directly access the memory locations that are present inside the RAM. Okay, and it is not required to travel through all the memory segments to obtain a particular data. Okay, so the memory address will be specified, and from that memory address we can directly procure the data. Okay, so that is a peculiarity of RAM. Okay, so this RAM or read or write memory is divided into again some three types. Okay, one is SRAM or static RAM. Second one is DRAM or dynamic RAM. And the last one is NVRAM, that is non-volatile RAM. Okay, so these are the different types of RAMs that are available. Okay, so first we will look into static RAM. Okay, so what is this static RAM? So the static RAM will store data in the form of voltage. Okay, so normally it is made up of flip-flops. So all of you know what is a flip-flop. Okay, so a flip-flop can store 1 bit of data. Okay, so like that thousands and millions of flip-flops will be present inside the static RAM. Okay, so a typical static RAM is implemented using 6 transistors or 6 MOSFETs are required for developing a static RAM. Okay, so these 4 of the transistors out of these 6, 4 of these transistors are used for providing the latch or flip-flop part of the memory cell, and 2 for controlling the access. Okay, so an access control will be provided for each and every bit. Okay, so the static RAM is the fastest form of RAM that is available. Okay, it is having very high speed. Okay, so it has networking and switching capabilities because we are providing 2 transistors for controlling operations. So by using that we can provide networking and switching capabilities. Okay, so this is the structure of a SRAM cell. Okay, so these are the 4 transistors that is used for storing, and these 2 are used for controlling. Okay, next one is dynamic RAM. Okay, so dynamic RAM stores data in the form of charge. Okay, previously in static RAM we used voltage. Okay, here in dynamic RAM the data will be stored in the form of charge. Okay, so these are made up of most transistors gates. Okay, this is made up of most transistor gates. Okay, so the advantage of this DRAM, okay, is high density and low cost compared to SRAM. Okay, so here if you see it requires only one transistor and one capacitor. Two components are required. Okay, previously in the case of SRAM, we require 6 components. Okay, 6 transistors to store 1 bit. Okay, here in order to store 1 bit, we require what? Only 2 components. Okay, from 6 it is reduced to 2. Okay, so we can save 4. Okay, so obviously the size will also reduce. Okay, okay, so if SRAM is using 6 components for storing 1 bits, it is using only 2 components. Okay, so the area can be reduced. Okay, so within a specific area we can incorporate more number of bits. Okay, so it has a disadvantage also. Okay, since it is the bits are saved as charge, so it will get leaked off with time. Okay, and to prevent this, okay, we need to refresh it periodically. The refreshing process is required, so for that purpose additional refreshing circuit is required. Okay, that is one disadvantage of this DRAM or dynamic RAM. Okay, so these special circuits like dynamic RAM controllers are used for refreshing operation. Okay, so this refreshing operation is done periodically in milliseconds interval. In every milliseconds we have to refresh. Okay, so that is the disadvantage of DRAM. And the last one is non-volatile RAM. So normally I told RAM means volatile. If the power is gone, it will be gone. Okay, the data will be gone. Okay, so here in non-volatile RAM, we will connect a battery backup. We will connect a battery backup to the RAM. Okay, so it can be a static RAM connected with the battery. Okay, why we are using why we are not using dynamic RAM? Because dynamic RAM needs a refreshing circuit also, so it will consume more battery. That's why we are using a static RAM, and a minute battery will be connected to the RAM as shown in the figure. Okay, it will provide an external supply. So even if the power is gone, okay, the data will be present inside that thing. Okay, so this memory and battery are packed together in a single package. Okay, so we can use this NVRAM. Okay, so it is used in operations such as we require a non-volatile operation. Okay, so this lifetime of this NVRAM is expected to be some 10 years. It is there. Okay, so an example for this NVRAM is DS1744, that is developed by Maxim Delas. Okay, that is a 32 KB NVRAM. Okay, that is an example for this NVRAM. Okay, so NVRAM simply means a RAM plus a battery. Okay, so that when the power is gone, the data will not be gone. Comparison of SRAM and DRAM cell. Okay, so SRAM cell is made up of 6 CMOS transistors. Okay, 6 MOSFETs are used for manufacturing. Okay, here a DRAM cell is made up of a MOSFET and a capacitor. So what is meant by cell? A cell is capable of storing 1 bit. Okay, and SRAM, it doesn't require refreshing operation. It doesn't require refreshing operation, but the DRAM requires a refreshing. Okay, then the disadvantage of this SRAM is more expensive, but DRAM is less expensive. Okay, and SRAM is very fast in operation, and a typical access time is in the range of nanoseconds only. Okay, so that is the benefits of what SRAM. Okay, DRAM cells are less expensive, okay, but operation is low, that is slow in operation due to refresh requirements. Okay, every time it has to be refreshed. Okay, so the typical access time is 60 nanoseconds. Okay, and the write operation is faster than the read operation. Okay, so these are the differences between SRAM cell and DRAM cell. Okay, so thank you for listening to this lecture.